Hi, I'm Rich with insideHPC. We're here at ISC 2017 in Frankfurt, and I'm here with Sunita and Michael Wolfe. But Sunita, let's start with you. We're here to talk about OpenACC. Can you tell us, what is OpenACC and who does it help?
OpenACC is a directive-based high-level programming model, and it is meant for those that would like to, take their code, not struggle with the programming, work on the science part of the code, and still be able to migrate their code on more than just one platform. So OpenACC currently supports multi-core GPUs, and we have other compilers like Sunway, and we have Omni compiler. These are some of the research compilers like Omni compiler that also supports OpenACC. So it is allowing the domain scientists to take their applications and be able to insert directives, hints that the compiler picks up and executes the code and targets the underlying platform.
So Sunita, I know you're one of the champions of these hackathons, GPU hack. Can you tell us about those?
Sure. So Fernanda Farter from Oak Ridge National Lab, it's a little baby, and we are calling us organizers as little babysitters. So, so last week there was one of these hackathons at the Brookhaven National Lab, and this is one of the several hackathons that has happened since 2014. And it's fascinating to see that we have approximately around 60 codes at the moment that has, come across these hackathons. And the science varies from computational fluid dynamics, lattice QCD, cancer research, and it says physics, there is chemistry, there is material science, what have you, right? And it's growing because we are getting numerous applications now, and we are in lack of bandwidth, lack of room capacity, lack of mentors, for lack of better words, but it's great. It's really great. And so it's scaling, as we can see. We started off with a few per year. Now we have almost 5 per year across the globe. So it's not just the US. And there was one at UDEL last year. So there was a university setting and students, undergrad, postdoc, faculty. So the profile of the team also is like very diverse, which brings sort of, excitement and enthusiasm to these hackathons.
That's great. Okay, so let's switch gears here a little bit, Michael. Why is OpenACC important to what you do? At PGI, you guys are about compilers and making things go fast. Does directives get in the way of that, or does it help?
That's an interesting way to phrase the question, Rich. So we're all about performance.
Yes.
But the users that we're targeting here, they want performance, but they want two other things. They want ease of programming as much as possible, and they want portability. Because you don't know what system you're going to be running on, or what system the users of your code will be running your program on. Think of an independent software vendor, an ISV application. They don't want to have to write a different version of their code for a GPU accelerated system than for a multi-core CPU, and they want to make sure it's going to port to the next CPU, go from x86 to Power. Future, you're wanting to go to ARM, for instance. You want to go to a GPU today, you want to recompile for the next GPU without having to return your code. And as Sunita said, these scientists, they're domain experts, they're not computer science experts, they're not computer architecture experts. The advantage of directives, I can put in one set of directives and use a compiler like the PGI compiler to recompile and target for different architectures. And we had a great deal of success with that. And in fact, today, we've been announcing there have been some of the top applications in HPC are using OpenACC to target GPUs, and some of those are using OpenACC as well to target the multi-core. It's a great validation of the OpenACC promise, which has always been performance portability.